Scientists always need several sources of evidence to support any scientific theory. Today, scientists use the fossil record, biochemistry, embryology, and biogeography to support the theory that change has occurred in populations over time, or evolution has occurred. The first piece of evidence is the fossil record. The fossil record is comprised of preserved organisms or proof of life. When analyzed together, dated sequences of fossils can show the change in a population over time. Scientists can date fossils, like speed dating fossils. Anyhow, scientists can date fossils by observing which layer of rock they originate from. The oldest rocks are at the bottom of the rock layer. The newest fossils are at the top. So if you're looking for the young ones, go for the ones on top, if you know what I mean. Thanks to advances in modern technology, it is also now possible to analyze the DNA and amino acid sequences of organisms. Shared sequences of genetic material tend to suggest common ancestry. Two organisms that have evolved from the same ancestor might have a high percentage of DNA or amino acid sequences in common. For example, in this chart, humans and chimpanzees have the exact same amino acid sequences for this hemoglobin molecule. That means that they are very, very closely related evolutionarily. Information gathered during early development of different species can also be used as evidence of evolution. The embryo is a developing baby, and many organisms that are related or have common ancestors have similar embryonic developments. These are three pictures. This one is of a pig at 30 days in development. This is a human at 9 weeks, and a lemur at 3.5 weeks. They all look pretty similar to me. Organisms often may look identical for the first few weeks or even months, again suggesting this common ancestry. Biogeography is a study of how organisms are distributed across the world. Through the study of biogeography, scientists can observe the effect of different habitats on organisms who are separated geographically. I have 3 different species here. They all live in very different habitats, and they have adapted to those habitats over time. The last thing I'll leave you with is about reading a cladogram. A cladogram shows the relationship between different organisms. Common ancestors are shown at the intersection between 2 organisms. The intersection is any place that lines meet. Traits in a cladogram are cumulative, meaning that a certain organism has all the traits of organisms that came before it. So in this case, amphibians have 4 limbs, a bony skeleton, and vertebrae. Those 4 limbs, bony skeleton, and vertebrae are also shared by anything that comes after amphibians evolutionarily. So a crocodile, for example, has these eggs with shells and an amniotic egg, but it also has the 4 limbs, the bony skeleton, and the vertebrae.